In this video, we're going to look at how we can use ratios to find the coordinates of an unknown point along a line. For example, imagine that we had this graph here with a line segment between at 2, 1 and B at 8, 10, and then separately we were told that an unknown point C lies somewhere along the line segment, so that the ratio of AC to CB is 2 to 1. How would we find the coordinates of point C? Well, the first thing we need to do is think about what the ratio 2 to 1 really means. And basically, it just means that the A to C section, so the distance between A and C, is 2 times bigger than the CB section between C and B. In general, though, it's more helpful to think about it as a fraction, and to convert ratios into fractions, we just take each of the numbers, so the 2 and the 1, which become the numerators of our fractions, and then put the sum of both of them as the denominator. So because 2 plus 1 is 3, we put 3 on the bottom to give us 2/3 and 1/3. This means that point C should be somewhere around here, so that from A to C is 2/3 of the entire line segment, and from C to B is just 1/3 of the line segment. Now I know that on this graph here we could just read off the coordinates of C using the X and Y axis, but in exams you won't know exactly where to put C at first. So next we're going to go through how you can figure that out. The first thing to do is to think about how long the whole line is in terms of the X and Y axis for. Example, the X values change from 2 at A to 8 at B, so that's a change of 6, while the Y values change from 1 at A to 10 at B, so a change of 9 in the Y direction. Then, because we know that C is 2/3 of the way between A and B, we just need to find 2/3 of the change in X and 2/3 of the change in Y, because that would tell us how far we need to move along the X-axis and up the Y-axis to get from A to C. So, for the X-axis, let's do 2/3 of 6, which is 4, and 4. The Y-axis will do 2/3 of 9, which is 6. Then all we're going to have to do is add these values to our point of coordinates, and that should give us the coordinates of C. So if we add 4 to A's x-coordinate of 2, that will give us 6 as the x-coordinate of C. And if we add 6 to A's y-coordinate of 1, that will give us 7 as the y-coordinate of C. And that's it. We've now found that C is at 6, 7, which is 2/3 of the way between A and B. Let's try an exam-style question this time. So this question says that points A and B have the coordinates -6, -11, and 9, 14 respectively. Point C lies on the line segment between points A and B such that AC to CB is 3 to 2. Find the coordinates of point C. Now, for questions like this, if they don't give you a graph as part of the question, it's normally going to be a lot easier if you just sketch one out quickly, and because it's just for your own benefit, you don't have to worry about it being perfect. For example, you might not even put numbers on the axis, you just put your 2 points roughly where you think they should be. So for this question, we can start by putting point A down here at roughly where we think -6, -11 should be, and B up here at 9, 14. And if you put it somewhere slightly different, like down here or over here, it really doesn't matter. It won't affect our working out at all. Next, you want to draw your line segments between A and B and put point C roughly where you think it might be, and again, it doesn't matter if you don't put it in exactly the right place. The graph is only to help you understand what's going on in the question. Next up, we know that the ratio between these two parts is 3 to 2, and remember, that means that this part is 3/5 of the line, and this part is 2/5. To be clear, at this point, all we've done is take the information from the question and sketch it out onto a graph so that we can more easily understand what's going on. To actually answer the question, though, and find C, we need to do 3 things. First, we need to find the difference between the X and Y coordinates of point A and point B, so the change in X and the change in Y. Then second, we need to find 3/5 of that difference. And finally, third, we need to add that 3/5 of the difference onto our coordinates. So for step 1, the difference between -6 and +9 is 15, so the change in X is 15. While the difference between -11 and +14 is 25, so the change in Y is 25. Then for step 2, 3/5 of 15 is 9, and 3/5 of 25 is 15. And then finally, for step 3, we need to add 9 to A's x-coordinate of -6 to find that C's x-coordinate is +3, and add 15 to A's y-coordinate of -11 to find that C's y-coordinate is +4, and that's it. We've now found that C's coordinate is 3, 4. That's it for this video, so hope you enjoyed it, and cheers for watching.